Welcome to Akbar Academy. Today we are going to be doing the 2021 Paper 4 Variant 1, question number 1 from the 0625 Cambridge IGCSE syllabus. So let's get stuck right in. Question number 1, a skydiver of mass 76 kilograms is falling vertically in still air. At times t equals 0, the skydiver opens his parachute. Figure 1.1 is the speed time graph for the skydiver from t equals 0. So let's go through a couple of things that might throw off some students. First of all, t equals 0. What does that mean? What the examiner's really saying there is, as far as we are concerned, this is where we start. Okay, when we say t equals 0. Could have been 12 in the afternoon, it could have been 3 in the afternoon, it could have been 6 in the evening. But as far as we are concerned, t equals 0 is where our journey begins. Now, the fact that they're saying still air is to try to stop you from kind of bringing in things like wind or talking about any kind of thing like that later on in the question, very likely. So we will look at that later on. So let's get into the actual question itself. Use figure 1.1 to determine the deceleration of the skydiver immediately after the parachute opens. Now, we've got to be careful here, because if you look at this graph, it looks fairly curved from the beginning, all right? Now, I can see that there is a small region where there is a straight line. What is the formula for acceleration? It's a equals v minus u divided by t. When they're asking for deceleration, basically they mean a negative acceleration, the fact that it's slowing down. Now, you could use the very small straight line region of this graph, but I would tend to advise against it. And what I would be suggesting to my students is to draw a tangent. Now, how do we draw a tangent? Well, basically what we do is we kind of cross a point once and we extend this line all the way down. Now, let me do my best to do this on screen. So something like that. Okay, so there is my tangent. Now, why would I do this? Because basically, if you've only got a small amount of straight line to play with, in other words, to do the calculation on, we teach our students that basically that gives rise to an inaccurate answer. Could it be accurate? Of course it can be, but it's more likely to have errors in it. So by extending the line out, making it long like I have, I can now find out the gradient of that complete straight line. Why does it work? Well, basically, because I'm drawing a tangent to the point all the way up here. Remember, they want to know the acceleration, or sorry, the deceleration at the beginning, which has to be here. Now, if we look at this, that begins at 58 meters per second. How do I know? Well, let's take between 20 and 40. I hope you can see there are 10 boxes. What is the difference between 20 and 40? Well, it's 20. How many boxes do I have? 10. What is 20 divided by 10? 2. It means each box represents 2 meters per second. And if you look up here, I'm just one box below 60, so it's 58 meters per second. Obviously, it goes all the way to 0 because the tangent I've drawn. And then what is the time? Well, let's look between 0 and 1. How many boxes are there? There are 10 boxes. What is the difference between 0 and 1? It is 1. So 1 divided by 10 tells me each box is 0.1. Now, you might wonder, why did I go to 20 and 40 and 0 and 1? The lines here, the lines also here, I want to make sure the line didn't obscure the measurements, what I'm actually trying to tell you that it stands for. So if we go here, we've got 1.1, 1.2, 1.3, 1.4, 1.5. Okay, slightly beyond, but we'll go with 1.5 seconds. In questions like this, where you're expected to draw a tangent, there's always a range of results. So the actual range of results for this question is between 35 and 43 meters per second. Now let's actually find out what the answer here is. So A equals V minus U divided by t, okay? And now remember V's final velocity, so it was 0 minus 58, that's what I started with, divided by time, which is 1.5. Stick that into my calculator, and I get 38.7 meters per second squared. So I'm well within range. 38.7, I've actually rounded that meters per second squared. It's actually minus, but then in the actual answer area, we can drop the minus to say that it's 38.7 meters per second squared. And it's pretty much in the middle of that range, which tells me that I've got a very good answer and I drew a very good tangent line. Go me. Moving on. The force due to air resistance acting on the skydiver immediately after the parachute's open. So notice what they're doing here. They're mixing a motion question with forces. So F equals ma, and I remember that the mass is 76. So 76 times 38.7. Now remember, this is going to be based on your tangent line. I get 38.7, you might get 35, you might get 42. As long as it's within the range that I've stated, then you might get a different answer here. So 38.7 times 76, and I get 2941.2 newtons. Now, very often I'm asked by students, do I have to leave the answer in standard form? Now, listen, at IGCSE level, you don't, okay? Especially for the Cambridge syllabus, you don't have to, but your teachers are teaching you good habits, but it is one less thing to worry about in the actual examination itself. Don't leave the answer as a fraction. That's the no-no. Next. Explain in terms of the forces acting on the skydiver, his motion between 0 and 6 seconds. Now, here is a question to be careful of in actual exams. The graph itself does go to 6 seconds, so we're lucky here. But very often, you're given questions where the graph might, span 15 seconds, 20 seconds, and the examiner still only asks you for 6 seconds. What happens here quite often is students will end up telling the examiner about the entire thing, think they've done a brilliant answer, which they probably have, but if they've only asked you for the first 6 seconds, you don't tell them about the entire graph. You will not be awarded marks for such things. So look, if we look at the first 6 seconds, let's kind of split this up into 3 sections, if you like. Let me rub this out so it's nice and clear. Let's call the kind of section number 1, if you like, right at the top. Let's call this number 2. And let's call this number 3. This is for your clarity. Okay, you can do this in an exam, but it's more for you. If you look at number 1, the skydiver's kind of rapidly decelerating at the beginning. Why? Okay, well, basically, air resistance is much, much bigger than the skydiver's weight. He's pulled the parachute. Now, if you look towards number 2, the skydiver is still slowing down, but at a smaller rate than at the beginning. Why is that? Well, basically, when an object speeds up, air resistance increases. Then it stands to reason if an object slows down, air resistance also decreases. So what's happening here is skydiver slowing down, the weight's not changing, but the air resistance is decreasing because the skydiver's slowing down. And then at number 3, the horizontal line, the skydiver is moving at terminal velocity. Why is the skydiver moving at terminal velocity? Because now air resistance equals weight. The air resistance is decreased enough to now cancel out or balance with the weight. The resultant force is 0. So now the skydiver is going at a constant speed or terminal velocity. You know what? For the sake of this question, I will stick in those numbers, although you don't have to. But basically, number 1, air resistance much greater than weight. So skydiver decelerates. Let's just stick number 2 in here, might run out of space. As speed decreases, air resistance decreases. And number 3, air resistance and weight are equal. Skydiver moves at terminal velocity or constant speed, whichever one suits you. Sorry, it's a little bit crushed at the bottom there, but that's basically the 3 parts. And then there's always going to be a part that students don't like in a paper 4 exam, okay? Quite often in the questions. Explain why opening the parachute cannot reduce the speed of the skydiver to 0. I know that kind of question would throw off a lot of students. See, for the skydiver to go to 0, well, if the forces are now balanced and the skydiver's going at a constant speed, well, the only way the skydiver can now stop is if the force up the way is bigger than the force down the way. Now, that will happen when the skydiver touches the ground. The skydiver will rapidly decelerate, and the force up the way will be bigger than down, and the skydiver will stop. And when the skydiver stops, incidentally, on the ground, the air resistance will be 0. So why can't the skydiver speed be reduced to 0 whilst the skydiver is in the air? Well, there's a couple of ways of looking at this, but for me, I'm going to go with what I think, and I hope you agree, is the simplest way. The skydiver is going at terminal velocity. Air resistance and weight are balanced. The air resistance is not going to increase now. The parachute's already open. So basically, the forces are balanced already when the skydiver's moving. Okay, so it can't reduce to 0. There's already a speed when there is air resistance. For him to stop, air resistance needs to be 0, and that's only going to happen when he hits the ground. So let me try to summarize this for you. The forces are balanced when speed is greater than 0 okay, speed cannot decrease further whilst in the air. Truth is, that last part is more for you students, because the speed can decrease if he hits the ground, but whilst he's in the air, the speed is not going to decrease anymore. And yeah, that's basically that.